What's going on YouTube? Coach Carr here, bringing you another video. This one is on quadrilaterals and we're going over pages 11 through 13. It focuses mostly on slope. So I hope you enjoy. Okay, so the success criteria is I will be successful when I can use point slope form for parallel and perpendicular lines. And the learning target is to prove the slope criteria for parallel and perpendicular lines and use them to solve geometric problems. Okay, so we are on page 11. The top of it says to describe the steepness of a line, we use slope. So we're doing a quick review on slope. Now, you can hear it as slope, rate of change, gradient, rise over run. The actual equation for it is y2 minus y1 on top, and then x2 minus x1 on the bottom. Now, an example of a positive slope is a line that's going upwards, so that could be an example there. A negative slope has to be going downwards. If it has a slope of 0, the way I remembered it is as OK. So with these, it's not going to go up or down anymore, but it is going to go to the left or right. So this could be an example of it. Now the undefined slope, the way that I remember it is no. So if 0 is on bottom, it can't work. If 0 is on top, it would have worked. So for this one, an undefined slope would be like a line going up and down, going vertically. So now when we look at the bottom, I'm just going to move it up slightly. Equations of a line. Slope-intercept form, this is the one most of you are pretty well versed in. It's saying y equals mx plus b, where m is the slope and b is the y-intercept. So an example would be like y equals 5x plus 2. So the slope would be 5, the y-intercept would be 2. Point slope form, which is what I want you to be focusing on, because that's what our success criteria deals with. The x1 and the y1 is a point. So if you need to have a point for it to go through, that's what you're using. And m is the slope, just like how it was for the y-intercept. So an example could be like y minus 2 equals 5 times x minus 3. So in this case, my original point would have been 3, 2. That would have been the original point. So now I'll move it up slightly. The last one on here is the standard form, where you have ax plus by equals c. To find the slope m, you would want to do the opposite of a over b. To find the y-intercept, you would want to do c over b. And an example I could give is like 2x plus 3y equals 2. So that's like a way you could see it shown. Okay, so now we're on page 12. On the top of it, we're first talking about the parallel lines. So parallel lines postulate: in a coordinate plane, two coplanar, so on the same plane. So two coplanar lines are parallel if and only if they have the same slope. So the slope has to be the same for the two lines in order to be parallel, which makes sense because they're not ever supposed to touch. So there are two symbols. They could be two lines straight up and down, or it can be the two lines that are slanted. that is the ways that we can do the symbol for parallel lines. The next one is the perpendicular, and in this one, in a coordinate plane, two coplanar, so again they have to be on the same plane. Two coplanar lines are perpendicular if and only if the slopes are opposite and reciprocal. So opposite tells us that they change signs. So if it was positive, it goes negative. If it was negative, it goes positive. And reciprocal says we flip the fraction. So if it was 1 over 2, now it'd have to be negative 2 over 1. So the product of this slope would mean that it is negative 1. Now the symbol for this is like the upside down T. Alright, so we're looking at number 1 on page 12. It says, in a right trapezoid ABCD, BC and AD are parallel. And AD is contained on the line whose equation is y equals negative 1/2 x plus 10. Part A wants us to find the slope of the line containing BC. Briefly explain how you got your answer. So they told us earlier BC is supposed to be parallel to AD. So according to what it says here. In the notes just above, it's saying that if they are supposed to be parallel, they have to have the same slope. So if we find out the slope here, we're going to be able to find what the slope of BC has to be. So for part A, the slope is what the m would be. So this is actually in slope-intercept form. So y equals mx plus b. So this here in front of the x is our slope. So this one has to have a slope of negative 1/2 because they are supposed to be parallel, which means it is the same slope. So when they said to justify it, this is how I'm justifying it, is they're supposed to have the same slope. Next, part B. So part B says write an equation in point slope form of the line that contains BC if B is located at negative 2, 7. Show your work and justify your answer. So point slope form, again, this goes to our success criteria. In this form, it is y minus y1 equals m times x minus x1. So the only question is, what's our y1 and x1? Well, that's going to be whatever point they want us to be located at. So in here, this is my x1, this is my y1. So I can plug that in to this equation. And we already found what my slope has to be earlier. So in this, we would have y minus 7 equals, now the slope has to be the same, so negative 1/2 times x minus, now it's minus a negative 2. Minus a negative 2. So what happens when it's minus a negative? Well, the sign has to change to positive. So now this is going to distribute into it. So we have still y minus 7 on this side equals negative 1/2 x. And then negative 1/2 times 2. So it's the same thing as having 2 over 1. So you do the numerators together, denominators together. So I would have negative 2 over 2. So if you have the same number over each other, so it's negative 2 over 2, that is the same thing as it being negative 1. So in point slope form, I can just leave my answer like this. This is point slope form right here. So there I could just leave it like that. Now part C is supposed to be writing the equation in slope-intercept form of the line containing BC if B is located at the negative 2, 7. So like I just said, it's located at the negative 2, 7, just like the problem before. So really, what we can do is just continue what we did in point slope form and just turn it into y equals mx plus b, which is the slope-intercept form. So I'm just going to rewrite what I have written here, y minus 7 equals negative 1/2 x minus 1. So in order to get it into the slope-intercept form, I need to get y by itself over here. So the way I'm going to do that is by adding 7 to both sides. When I do that, I now get y equals negative 1/2 x plus 6. And that would be in slope-intercept form. Okay, so now we're looking at page 13, number 4. It says in a right trapezoid ABCD, AB is perpendicular to AD, and AD is contained in the line y equals negative 1/2 x plus 10. So part A wants us to find the slope of the line containing AB. Well, earlier they said AD and AB are supposed to be perpendicular. So if they're perpendicular, it needs to have the opposite and reciprocal. So if the original slope is negative 1/2, opposite tells us it has to change the sign. So I know it's now going to have to be positive. Reciprocal tells me I need to flip the fraction. So the new slope has to be 2 over 1, which is the same thing as 2. And the reason is because it is perpendicular. That's my reasoning. That's how I'm justifying my answer. It had to do the opposite and reciprocal. So next is the part B. Part B says write an equation in slope-intercept form of the line containing AB if B is located at 0, negative 4. Okay, so what you want to do is use the point slope form to make it so it can be turned into slope-intercept form. So again, y minus y1 equals m times x minus x1. So the only question is, what's my y1 and x1? Well, that's what we were given over here. So remember, x comes first, y is second. So now what we're going to do is plug these in. So y minus y1 is negative 4, so minus a negative 4 equals the slope, which is now going to be 2, because remember it's supposed to be perpendicular, so we did the opposite and reciprocal. And then x minus x1. And x1 in this case was 0. So here, y minus a negative, that changes the sign. So really what we have over here is y plus 4. Then you have 2 times x, and then 2 times 0. So 2 times x is 2x. 2 times 0 is 0. Since it's 0, I don't necessarily have to write it down. So in order for it to be in slope-intercept form, I do know that y has to be by itself. So the next step here would be to add 4 to both sides. That's so it cancels out right there. And now you have y equals 2x plus 4. So that would be in slope-intercept form. Thank you so much for watching. That's the end of this video. Make sure you do exit slip number 4 after you show me all the notes that you just did here. So make sure to ring that bell, do all the notifications, and thank you.